Hi, I'm Nithya Sambasivan. I'm an HCI researcher at Google Research, part of the PAIR team and the Google Research India lab. And I'm here to talk to you today about data as a boundary object in the ML pipeline. So I'm representing the work of multiple Googlers and collaborators, including Kristen Olson, Shivani Kapania, and other folks at Google. So data is the critical technical infrastructure of AI. Data largely determines performance, fairness, robustness, safety, and scalability of AI systems. Data sourcing and labeling is an estimated 25 to 60% OPEX cost of ML projects. Paradoxically, for AI researchers and developers, data is often the least incentivized aspect. It is viewed as operational relative to building new models and algorithms. Humans power the ML data pipeline, from data collectors to raters to domain experts to developers. But human experiences and challenges in ML are less understood. As models become more commoditized, AI is increasingly expanding into high stakes domains where the safety aspect on living beings is high, such as in cancer diagnosis, wildlife detection, and credit assessment. It's not just about cat versus dog detection anymore. Data has often been attacked as a database systems issue, a legal issue, or a licensing issue, but we believe that human computer interaction has an important role to play in improving ML data quality. So, for the past year, we have conducted a systematic study of various actors in the ML data pipeline in multiple parts of the world. We've studied goals, values, practices, processes, and challenges around data of the various groups in the pipeline. Invoking Starr and Griesemer, we put forth that data is a boundary object in ML. It is robust, shared, and yet plastic enough where it is viewed differently along different value alignments by various groups along the pipeline. I will talk to you about this in more detail in a minute, but in brief, data collectors like frontline health workers who power many of the cutting edge, high stakes data sets see data as a tool for reporting and program delivery. Data is often orthogonal to their services, sometimes a burden. Raters are measured by their data outputs, making data an economic artifact for them. AI developers use data as code for ML, which then gets implemented into systems that then impact society. So let me start with a key observation of ours, which is that of data cascades in AI. So we define data cascades as compounding events causing negative downstream effects from data issues that result in technical debt over time. In our study of AI developers' data practices in high stakes AI, we observed prolific data cascades. 92% experienced at least one cascade. 45% experience two or more cascades. And this is troubling because of the domains that are high stakes that we studied. Data cascades are opaque and largely invisible. They're triggered by conventional ML practices from worlds of big data and viewing data as grunt work. Cascades have negative impacts, including abandoning projects, redoing data collection, and causing user harm. However, in our study, the data cascades were avoidable with intentional processes and practices. So, what are some factors causing these cascades? Incentives for novel model development over data rigor, limited data education in AI and ML, and the fact that it's sometimes difficult to create new data sets in cutting edge AI, and developers often make do with what they can get here. I'll give you two examples of triggers for data cascades. In high stakes domains, AI systems transition from well defined and understood environments to brittle deployments closely interacting with the physical world. A conventional ML practice of creating pristine training data sets in development led to system failures in production. So, even the smallest of artifacts like fingerprints, shadows, dust on the lens, improper lighting, and pen markings were reported to affect predictions. For example, in our study, a millimeter movement of a camera led to a road safety model failing in production. Another example of a cascade trigger is from the over reliance on data sense making in social and scientific contexts by AI developers, where they may have lower application domain expertise and engaging poorly with the domain experts here. Questions like, is this a fracture? Is this a village resident or a poacher? Is this a sign of preeclampsia? Actually require domain expertise. Moving to data raters, we find that one of the key aspects of their experience, that is, the rater user interfaces and their tasks, are rather poorly designed. Many people can draw a bounding box, but as AI gets implemented in more complex and subjective domains, the gap between who labels the data and who consumes the AI predictions comes into sharper focus. Labeling can be made more accessible and representative by designing tasks that account for rater environments, time allotments, usability, and speaking the language of data collaborators. For example, rather than providing room for ambiguity, many UIs today appear to force raters into binary decisions, leading to poor and inaccurate labels. Another example is of how functionality for productivity, like undos to rectify mistakes, providing feedback on tasks, specificity of tasks, pilot testing, and so on, are rather uncommon today. But we need more of these. And finally, on data collectors, as AI enters domains that have been hard to cover for governments and civil society, like COVID tracking and flood forecasting, many data sets come from frontline workers who are a part of NGOs, government services, and field partners, like community health workers and microfinance staff. While the workers have pride and prestige in doing good work, data collection for ML is often a burden, coming in the way of their goals and workflows. For example, recording values every few minutes for a medical data set can mean that a patient receives less care. Frontline workers do the invisible work to power high stakes ML, but they do not reap the benefits of ML capital. Instead, they are underpaid and ignored. Many ML projects in our study did not originally set out to create data literacy or transparency into ML use cases for the data workers. So, how can we move to a more proactive focus on data that results in safer and robust systems for all, and one that is grounded in ethics? We call for a shift from doing more with data to doing better with data. We see the use of imperfect and inaccurate system metrics like F1 score used for data quality instead as a proxy, which often measure the wrong thing and are too late to detect and course correct data cascades. How might we develop better data quality metrics, better documentation, and better iterations in model development? How might we take into account the fragility of the real world where things can go wrong fast? We should move from a culture of fear among raters to viewing them as partners. We should make tasks and user interfaces more data worker centric. How can data collectors benefit from ML revenue and prestige? Today, as it stands, there's an unfortunate lack of involvement and appreciation for application domain expertise in AI and ML. We need to incorporate domain expertise throughout the model development, not just in the problem formulation stage. We also see an opportunity for better tools for data. Several tools today focus on analysis, wrangling, and cleaning, but our research points to an opportunity to support the upstream work of defining dataset requirements and the downstream challenges of monitoring incoming live data, which can lead to data drifts, and measuring the impacts of data on society. We need better incentives for data rigor, including mainstream empiricism, rewarding data glue work in organizations, and reusability of data. Today, ML and data education seem to use toy data sets that are well labeled and West centric, like US Census data, but we need to train practitioners and researchers more on sourcing, collecting, synthesizing, and labeling their own data sets, which is often a competitive advantage. Thank you.